In the last video, we wrote the Java code to solve the pickup remote Karel world. And now we're going to do something pretty similar, just with a slightly different Karel world. So let's go ahead and we're going to write the MailToChair. So I'm going to go ahead and run this just so we can see what the world looks like, and I can talk about what we're trying to do with Karel in this world. So I don't know about you, but I happen to be pretty lazy. I live in an apartment where I live up on the 3rd floor of my building, and there's no elevator. So a lot of times when I come home, my mailbox is kind of right in the entryway on the 1st floor. So I'll open my mailbox, I'll grab my mail, I'll walk up the stairs, and I'm kind of too lazy once I get up into my apartment to actually open the mail. So for me, I throw my mail down on this little entryway table, and then I go about my business, and at some point I'll pick up the mail and actually sit down and go through it. Well, Karel is pretty similar. Karel in their house has this one chair, and this is Karel's mail chair. So like my front entry table, this is where Karel will actually put the mail when Karel comes in the house after a long day doing Karel things. So here's Karel's mailbox, here's Karel's mail chair, and it's going to be Karel's goal to get the mail from the mailbox onto the chair, and Karel will actually return back to their original position. And you're probably already starting to think, okay, what are the different Karel methods that I can use to do this? So let's go ahead and keep the little world open so we can keep looking at it, but let's double click to open up MailToChair, and let's actually write some code to make this happen. So remember, we're going to write all of our code inside this run method here. And let's go ahead and write the commands. Now, there's a couple of different ways that I could do this, right? I could make Karel go kind of forwards first and then up towards the chair, or maybe up first and then kind of to the right towards the chair. Let's start with kind of moving forward first. So I'm going to start by doing a move. Then I think I have to turn left. So now I'm here facing up. Then I can move. Then really I'm here facing up. Functionally, I want to turn right. We know that turn right is actually just 3 turn lefts. Now I'm here facing this way. I'm going to move so I can kind of get Karel into the mailbox. Now we're not going to be worried about why Karel's mailbox is actually bigger than Karel themselves. That's okay. Now I'm in the mailbox. Let's pick up our mail. So I'm going to pick beeper. Then I'm kind of like in the mailbox facing to the back of the mailbox. And again, here functionally, what I really want to do is kind of do a 180, like turn around, right? So let's do 2 turn lefts. Now I'm here. I have to get to the chair. We're not really going to worry about the fact that Karel's going to kind of float across here. We're just going to move, move, move. That should get me on the chair. Karel's kind of doing almost a handstand on the chair. And let's make it so that Karel's actually standing on the chair. So let's turn left, turn left. Now Karel should be in this position, kind of standing the correct way up and down. Let's put the mail on the chair. So I'm going to put beeper. Then I want to get Karel back to their original position. So I think I need to move. Then I need to really turn right, then move, then turn left. So I'm going to move, and then I'm going to do 3 turn lefts. Then I'm going to move, then 1 more turn left. Otherwise, Karel's kind of doing a face plant into the ground. Now we are getting to the point where our code is starting to look a little bit long. And especially as we're going through and doing more of this, you'll kind of hear me say that it's probably a good idea, or it may have been a good idea, to stop and pause. And maybe if I had written half of this, maybe if I had like stopped here, I could have actually run it and checked and made sure that what I had done so far was the correct thing to do. I did kind of just write this in one go. It's not crazy long, but there is a little bit of a benefit to writing a little bit of code and then testing it, and then a little more and then testing it. If I run this code right now and it doesn't work, it's actually going to be a lot harder for me to pick out where it's going wrong. Whereas if I had actually written part of it and then tested it, it would have been a little easier to do that. But Let's go ahead and compile. And it looks like mine is good to go since there were no errors from compiling. I'm going to close out of this window that's open so that I can run it. So I'm going to close out of that. Let's go ahead and run the MailToChair program. And I'm going to start this. Let's see if I manage to do the right thing on the first try. And there we go. Carol's back to their original place. This one is kind of funny because hypothetically, you could click the start program button again since I am kind of back in the original position that Carol started. But there's one thing that is a little different, which is now there's no mail in the mailbox. We know that making Carol run into a wall actually kills Carol, but you'll see here, actually trying to make Carol pick up a beeper that isn't there also kills Carol. I don't know if it's from the shock of expecting there to be a beeper and there's not, or what's going on. But unfortunately, that will also kill Carol. Cool. So this is the MailToChair program. Again, fairly straightforward. Ends up being pretty similar to the one that we did before, except maybe a little bit longer. We have kind of a few more methods that we've used in there. So one thing that I do want to talk about is this idea of Carol turning right. It is a little ridiculous right now that to turn right, we actually have to turn left 3 times. You would think that Carol, who knows how to turn left, could have a way to turn right. It is kind of dumb. We've talked about one method that every Carol program has, which is this run method. This is the code that happens when I actually click this start program button. What you may not have known until now is that we are actually allowed to also write our own methods. Carol has 4 things that they can do right off the kind of robot assembly line, right? Carol can move, turn left, pick up a beeper, and put down a beeper. But we're also allowed to tell Carol other things that they could do using those 4 commands. So let's do this. Let's write an entirely new method to actually tell Carol how to turn right. So down here, you can see I'm not in the run method anymore. I'm right below it. I'm going to write public void turn right. And inside this method, this is going to act as almost kind of a set of instructions or a recipe that tells Carol, how do you turn right? And we know how to turn right. It's turn left 3 times. And now that I have this inside of my Carol code, anywhere that I want to do a right turn, I no longer have to type turn left 3 times. I can actually use this turn right because now I've told Carol what is the correct way to turn right. So I can see here, I've got 3 turn lefts. Now I can turn right instead. And I think up here, I've got 3 turn lefts. Now I can turn right instead. Now, what was the advantage of doing this? I think a little bit of the advantage is this idea of readability. It's a little harder to kind of read through the code that I had before and figure out what's going on. Now I can kind of read through my run method here, and it's actually pretty easy to tell what Carol is actually doing. It's a little easier to read the words turn right than to read turn left 3 times. The other advantage of this is that maybe if I need to turn right a whole bunch of times, this actually ends up making my code overall shorter. In this particular case, I don't think it really makes it all that much shorter, but in general, oftentimes kind of making a new method can make your code shorter if it's something that you're reusing over and over again. There's one other thing that we do in this code, I think a few times, which is that it might be nice to have a method called public void turn around. This is the method that will make Carol kind of do a 180, right? And weirdly, what is a turnaround? It could be 2 turn lefts, or it could weirdly be 2 turn rights. It's a little funky to make it 2 turn rights because then what am I going to do? I'm going to turn left 6 times. So let's just do 2 turn lefts. Otherwise, Carol's going to take forever to do anything. And now anywhere that I turned around in my original code, I can replace. So here, let's replace this with a turnaround. And up here, let's replace this one with a turnaround. And you might be arguing like, it doesn't really seem like it improves my code all that much since this was really only 2 lines. And you might be true. You might be correct. But we're just kind of doing this right now for the sake of practice. Now, I want to mention a few things here before I have you kind of work on your next Karel program on your own, which is you're going to watch me type a lot throughout class. And right now, the way that I've been typing, I've been making my indentation pretty perfect, which means that every time I'm kind of typing in somewhere that has these curly braces, I've indented everything that's kind of inside of those curly braces to be kind of one tab in. Technically in Java, I don't actually have to do that. And I'll show you what I mean by that. I can compile this. This will compile. I can actually have things kind of tabbed any way that I want, and Java actually doesn't really care all that much. This will still compile and it'll actually still work. The one advantage, I think, to having your stuff indented correctly, having your code kind of all of the lines indented nicely, is that, again, it makes it a lot easier to read. It's not all that crazy to look at this and figure out what's going on. It's more just why. I've worked with a lot of people who have been kind of starting out learning, and there's kind of a habit to just not tab in anything, right? You might have some code that actually looks kind of like this. And I just discourage you away from doing that, just because I do think that the indentation actually makes it easier to see kind of which code belongs inside which curly braces. I think this is a lot easier to read than kind of what I had before too. So I would kind of encourage you to stick with my indentation as you're following along. Again, it's not the end of the world if your indentation is a little bit messier than mine, but it's generally a good idea to kind of try to do things the right way. One other thing I want to mention, could I have made this r lowercase? Could I have called this turn lowercase r right? Yeah, I totally could have. I'd have to change them up here, but I could have. It is a Java convention to actually name your methods in this way that I've been doing, where the first letter of the first word is lowercase, and then the first letter of all the words after that are actually uppercase. This is something called camel case. It's just a convention when you're writing code in Java. We use this for methods and other things you'll see as we keep going through this class. Part of the reason I'm bringing these kind of common conventions up, things like capitalization and indentation, is that my goal is to teach you how to be a good programmer, not just how to get your code to work. And part of being a good programmer means actually kind of adhering to these style conventions for different languages, which in Java means let's kind of keep our capitalization pretty standardized, and let's also keep our indentation pretty standardized. That will make your life easier when you're trying to read and figure out your own code, and my life easier when I'm trying to read and figure out the code that you submit to me. And it will make anybody else's life easier if you give your code to someone else and they're trying to read your code as well. So what you're going to do now is, now that we've made the MailToChair program work, you're going to go ahead and do the FeedDog program. So I'm just going to run this and show you what it looks like, and then you're going to do this one on your own. So this isn't a follow along. You're going to take a minute and write the code for this. So here's Karel. Karel's chilling out in their house. And look out here, this is Karel's dog bowl for Karel's very large dog. So what is Karel gonna do? Karel's gonna travel all the way over to the dog bowl, put some food in the bowl, and then Karel's actually gonna run back into the house because, oh my gosh, Karel's dog is so big that if she doesn't go back into the house, the dog might accidentally eat her. So one thing to know in this Karel world is that Karel actually does start with some beepers in her bag. So don't really worry about the fact that you don't have to like pick up dog food somewhere. You can just go, assuming you travel all the way to the bowl and use the put beeper command, there will be a beeper to put down. So take a minute and go ahead and do this FeedDog program and try to get that working. And in the next video, we're going to talk about some more complex things that we can do with Karel involving kind of sensing the environment around her.